For topic two, we're going to look at graphing lines using intercepts. So we already know what intercepts are. Those are points where your line crosses the X or the Y axis. And what's really important to understand is what that means for the ordered pairs. So imagine we have our Y axis and now our X axis. So Y axis, X axis. And if I'm looking at an x-intercept, that is a point that lives on the x-axis. So any point on the x-axis, we would call it an x-intercept. So this is an x-intercept. And what you need to understand about these points is to get to an x-intercept, from the origin, you move left or right. So you're definitely going to have some x value, positive or negative, but you never go up or down from the x-axis. So that tells me my y-coordinate is always 0. Okay? Now, if we're looking at a y-intercept, that is some point that lives on the y-axis. So let's say we have a point, let's do down here. So this could be a y-intercept. In order to get to this point from the origin, I never move left or right. Okay, so my x value has to be 0. And then I move up or down some value for y. So I'm going to get some positive or negative value for y. So all x-intercepts are going to be of the form x comma y for their ordered pairs. And then all all y-intercepts are going to be of the form 0 comma y for those y-intercepts, okay? So if we're trying to find the x-intercepts and the y-intercepts, remember, for the x-intercept, we let y equal 0, solve for x, and to find the y-intercept, we let x equals 0 and then solve for y. So at this point, you should kind of already know all of that. So that's just a quick reminder. So in order to graph using the intercepts, we have to find our x and our y intercept. We plot them on the Cartesian plane, and then you connect with a line including those arrows. Okay, so let's look at we've got one example, but an example in three parts. So example 3 says graph each equation using intercepts. Okay, so our first equation, we have 4x minus 3y equals 12. So let's find our x-intercept first. Well, to find an x-intercept, we let y equal 0 and solve for x. So I get 4x minus 3y, but y is 0. That equals 12. Well, 3 times 0 is just 0. 4x minus 0 is just 4x. So I get 4x equals 12. Okay? And then I need to divide both sides of this equation by 4. That'll undo that multiplication of 4 and x. Well, 4 divided by itself is just 1 times x. And then 3 divided by 4, or 12 divided by 4 is 3. Now, you don't want to stop here because this actually looks like an equation of a vertical line. So what we want to do instead is we need to remember this is an x-intercept, and we write our x-intercepts as ordered pairs. So let me fix that ordered pair. So we want to write this as x value is 3, y value we placed as 0, okay? So our x-intercept is the point 3, 0, okay? Now for the y-intercept, we want to let x equal 0 and then solve for y. So I get 4 times x, which is 0, minus 3y equals 12. Well, 4 times 0 is just 0. 0 minus 3y is just negative 3y, and that all equals 12. Okay, now to get the y alone, I need to undo the multiplication of negative 3 and y. So I would divide each side by negative 3. Negative 3 divided by itself is just 1. 1 times y is y. And then 12 divided by negative 3 is negative 4. So I would write this intercept as the ordered pair 0 for x and then negative 4 for y. Okay, so these formats that you see right here, you don't want to write your intercepts like this because this is tricky. It looks like equations of lines that are horizontal or vertical. So you want to avoid this format. You could say x-intercept equals 3, y-intercept equals negative 4, but I personally prefer the ordered pairs. Okay, so we want to plot these ordered pairs now. So let's plot our x-intercept. So from the origin, I would go to the right 1, 2, 3, and then I stay there. I don't move up or down. Okay. And then for the y-intercept at the origin, I don't go left or right, but I go down 4. So down 1, 2, 3, 4. I've got 2 points on my line, and you have to have at least 2 points. You can't graph a line if you don't have 2 points. You have to have 2 or more. And then just don't forget to put your arrows because this graph goes on forever and ever. That's why we add those arrows at the end of the line to indicate that, hey, this solution, this line being the solution, it goes forever. All right, next up we have 2x equals 3y plus 6. So let's do the same thing. Find the x-intercept. We let y equal 0, and then we solve for x. So in this case, I have 2x equals, and then on the right, I have 3 times 0, which is 0, and then 0 plus 6 is 6. So I get 2x equals 6. And then I need to get x alone, so I need to undo that multiplication of 2 and x. So to do that, I divide both sides by 2. 2 divided by itself is 1. 1 times x is x. And then 3 divided by, or 6, good grief, 6 divided by 2 is 3. Okay? So my x-intercept is the ordered pair 3, 0. Okay? And then we just repeat the process for the y-intercept. Remember, for the y-intercept, we let x equal 0 and solve for y. So I'm going to rewrite my equation as 2 times x, but x is 0, equals 3y plus 6. Well, 2 times 0 is just 0. So I get 0 equals 3y plus 6. We can move the 3y or the 6. It doesn't matter. I'm going to move my 3y. So I'm going to subtract 3y from each side. That leaves me with negative 3y equals 6. All right, the 3y's on the right just become 0. So 0 plus 6 is 6. And then I need to undo the multiplication of negative 3 and y. So I divide each side by negative 3. Well, negative 3 divided by itself is just 1. 1 times y is y. And then 6 divided by negative 3 is negative 2. So my y-intercept is the ordered pair, 0 for x, negative 2 for y. Okay, so we want to plot our intercept. So at the origin, I would move to the right 1, 2, 3, and then stay there. That becomes my x-intercept. And then if I go back to the origin and I go down 1, 2, that becomes my y-intercept, and I graph by connecting those points, extending, and then putting arrows on the end. Okay? Now, example C is kind of special. Okay? So something tricky is going to happen with example C, so we have to do a little extra work here. All right, let's start by finding our x-intercept. So nothing crazy so far. To find the x-intercept, we let y equal 0 and solve for x. So I get 2x plus 0 equals 0. Well, 2x plus 0 is just 2x. And if I have 2x equals 0, that means I have a product that equals 0. And we know in order to get a product that equals 0, one of those numbers that we multiply has to be 0. Okay? Well, 2 certainly isn't 0, so that means x has to be 0. But let's go ahead and prove it to ourselves by solving. We need to undo the multiplication of 2 and x, so I would divide both sides by 2. 2 divided by 2 is 1. 1 times x is just x. And then 0 divided by 2 is 0. So when I look at my x-intercept, I get 0 for x and 0 for y. And if I think about that ordered pair, that's really just the origin. Well, that tells me my y-intercept is the same thing. And if we need to prove it to ourselves, we can. So if we look at the y-intercept here, we let x equal 0, and we solve for y. Well, 2 times 0 is 0. 0 plus y is y. And then y equals 0. So we get the same thing. So if that's the case, we're in trouble. We can't graph using our intercepts because you have to have a minimum of 2 points to graph a line. So what do? We pick any other point, okay? You pick some value for x, find a corresponding y, and that gives you a second point, okay? So in this case, pick a second point to plot. So when we do this, I like to choose x and find y. So I'm going to let x equal, let's do negative 2. Okay, so I'm just going to arbitrarily pick that x is going to be negative 2. Okay, doesn't matter. You could literally pick any point on the planet. Okay, so if x is negative 2, I'm going to rewrite my equation replacing x with negative 2. Well, 2 times negative 2 is negative 4. I want to solve for y. In order to get y alone, I need to add 4 to both sides. So that tells me y equals 4. So my new ordered pair, I chose x to be negative 2, and I found y to be 4. So I've already got my origin. That's the x and the y-intercept. So I now need to plot, whoops, I wrote that down wrong. I now need to plot my other point. And again, you can pick literally any value for x and find your corresponding y. I just chose something kind of easy to work with. So from the origin, I'm going to go to the left, 1, 2, and then I'm going to go down, or I'm going to go, let me say that again. At the origin, I'm going to go to the left 2, and then I'm going to go up 1, 2, 3, 4. That is the point, -2, 4. All right, so we want to connect, extend, and Lord have mercy, don't forget those arrows. Okay, so there you have it. That is graphing using intercepts. Be on the lookout for a tricky situation like part C, but otherwise, this is a fairly straightforward, easy method for graphing equations. Okay?